Today we will be building this tkinter app, which allows users to upload an image, like an image of your refrigerator or whatever you have on your counter with some food elements. And then when you click generate recipe, it first connects with the Huggingface resnet 101 object detector, then gets the items from the image, then sends it to GPT-3 to create a recipe, and then it displays it right here. It's pretty cool. We're going to be learning about Hugging Face, and also we'll be using GPT-3 API. So let's begin. So we're going to be using Hugging Face for this. Hugging Face has a lot of cool models. If you go to models, you need an object detection model. So if you click on object detection, the first one is Facebook DETR resnet 101, and it does exactly what we want and need. If you scroll down, here's a code snippet that actually activates this and makes you be able to run API calls to it. So we need to install transformers. We need to install pytorch and transformers, also the pillow library. We click on documents and then click on transformers. Here you have some installation instructions right here. If you go to installation, we have to install pytorch. We're going to be using pytorch, not TensorFlow. It's creating a new environment. I'm using Anaconda prompt, so I'm going to be creating a Conda environment. I think Miniconda, Anaconda prompt has a better way of dealing with environments, but take a look if you like. And after that, we're going to be installing it. You can pip install it or Conda install it down here somewhere. So that's what we're going to be doing. Let's create our environment. Conda create. This is to specify the name, HF for Hugging Face, and you can also install a specific Python version. I will be installing Python version 3.10 for this particular environment. After we installed our environment, I'm going to activate it by saying conda activate HF, and now we're in that environment. Next, let's click on PyTorch. PyTorch is easy to install. We need the stable version. I'm running on Windows. Let's do pip install. Let's get the CUDA as well. So this is your code. You just have to copy it and paste it into your command prompt, and it should install PyTorch. It looks like everything installed without a hiccup. Pillow is installed as well, along with some other like NumPy library. Anyway, so from the installation instructions, I'm going to copy the conda install command and install Hugging Face transformers. And this should take a moment. Okay, it looks like Hugging Face transformers is installed too. Let's go back to the models, to object detection, the resnet 101, and let's just copy this code and come back to our Visual Studio. I have created a file called recipe_app.py, paste this in, and as you see, the transformers is lighting up because we need to set our environment. To set the environment in Visual Studio Code, you do Control-Shift-P and go to Select Interpreter, and we want to select the HF environment. Once you do that, the warning has disappeared. So when I try to run this, I'm getting an error saying that no module name char dead, and I did a quick search. Guess we need to pip install it, not sure why, but that's fine. Let's just quickly do that. Hopefully this will solve the issue. It's giving me another error saying that I need to install Tim library. So let's go ahead and do that. Okay, let me copy paste and install. Okay, after installing the Tim library, it's working. As you see, it's detecting a cat, remote, cat couch. I guess it's whatever this image is, which was probably the image from... Oh, okay. So it's detecting cats and remote controls. Let's try this one. We're going to make a recipe app. So I'm going to copy the image address. Let's replace this URL. Let's see if this will work. Let's run this. Okay, as you see, it is working. It's detecting an apple, orange, some knives, bottles, and bowls, stuff like that, which is mostly correct. It didn't detect the peppers, but maybe this is due to, if you look at this line right here, it says that let's only keep detections with a score of 0.9. And so threshold is set at 0.9. Maybe if we were to reduce it to 0.7, maybe we'll end up detecting more things, which the confidence level is a little bit lower. Okay, it's still not detecting the peppers, but that's fine. This is the model that we found, which works decent. So at this point, all we have to do is just print the names of the items and not like the confidence or anything like that, or the location. So I just want to get a list of the names of the detected items. I created a list here, detected objects. We need the results label, I believe. Let's see if this is going to work. And then let's just print it. Detected objects, and let's comment this out. Okay, this wasn't correct. We probably need this. So let's get this. Oops. And we need to make this an empty list and then maybe append the detected objects that append. Okay, perfect. This works. So we are just doing the same loop and then appending to an empty list the model.config.id labels label.item. And this is printing correctly. After this, all we have to do is just make an API request to GPT-3 and tell it to use only the vegetables and whatnot and to create a recipe for us. One quick way to get the API code for Python or Node.js, just come to OpenAI's Playground, select the model you want to use, set your settings however you want to. We're just going to leave it default. And then when you click on View Code, you can get a Python code or Node.js code. And all you have to do is just copy this and bring it into your code. We're going to need to pip install OpenAI, but so this is all you need. I'm going to retrieve my key from my environment variables. This should do it, and then this should make a request after we pip install OpenAI. Let's do that real quick. Okay, OpenAI is pip installed. We're no longer getting an error. We're getting our API key, and I've created a if string for the prompt. What I'm going to send to the GPT-3 is to create a recipe from the edible items from this list and insert the list, and then print its response. Let's see what happens. So the first time I tried it, added some additional items which wasn't on the list, like onion, vinegar, oil, and salt and pepper. So I changed the prompt to say only use what is in the list. And in the second one, it was more appropriate to whatever is in the list. It's, I guess, assuming you have some olive oil and lemon juice, which is fine. We could try to play around with the prompt and try to get it exactly. But so this works. So this gets us, this detects items from an image and then actually prints instructions to make a recipe out of whatever is in the, whatever objects were detected. So I wanted to add the ability to be able to use a local image. I just downloaded some vegetables on a countertop image, and I've saved it in the local directory, and GitHub Copilot wrote this for me. It's just, instead of using the URL, it's just actually using whatever image is here. So this is the image, and when we run it, we actually get a list of items from this, like apple, orange, broccoli, and then it creates a recipe based on that. So that's pretty cool. So now we have two options. We can upload an image or use a URL. Let's turn this into a tkinter app with a user interface in which the user can upload an image and then click generate recipe. And once the GPT-3 responds with the recipe, it's displayed in this nice little box. I think it looks beautiful too. It's pretty cool. To be able to do this, I have copied our original recipe _ app file into GPT-3 Playground. After I've copied it, I just said, turn this into a tkinter UI. User will upload an image and the recipe will be displayed in the tkinter window. And I said, make it beautiful. And this was the code. Let me just copy this again because I had to make a few changes. Because as you see, it didn't import the model from the Huggingface and the torch. So all we have to do is just get up Copilot complete it for us. And then another mistake that happens is when the tkinter label is created, it's given it the name label. And this is conflicting with the torch label that comes from the model. So I'm just going to change this to recipe. And then right down here, I'm going to let GitHub Copilot do some magic for me, just like that, and then this should work. Here we go. And what happens is with the label right here, the text doesn't wrap. So I'm going to say wrap the text with 500 characters and let GitHub Copilot redo this for us. And maybe let's do a background. Let's do light blue. I believe this should work. Let's run it. Oh, I had forgotten comma. Let's run it again. So here we go. We can upload the image again. It could be any image really, and then generate recipe. So first, object detection will happen with Huggingface transformer, and then once the detection happens, we are sending the recipe, the ingredients to GPT-3, so it can create a nice little recipe for us. You can obviously modify the style to any way you like, but so this works, and it's a quick little app. It took me less than an hour to do this, so hopefully you found it useful, and see you in the next video. Oh, and I just want to mention that I created a Discord server. For those of you who are interested, I'll put the link in the description, and hope to see you there.